So then let's start. The first stuff we need to worry about is shader. I'm assigning a new material. I'm grabbing a Redshift shader. Here I have the choice. I can use a architectural material, which is an old Redshift material that have been replaced with the Redshift material. They did leave it there because probably some people are still using it for different reasons, or maybe for old scene. In my case, I completely stopped using it. I'm using now only the Redshift material. You can use the Redshift Carpent. We will go more in depth and in detail about this one later. You can use Redshift Air, something I'm not using. That's why I will not be talking about, and it will explode the purpose of this video since we're doing just an introduction. Redshift Incandescent, we will talk about this one. The Redshift Material Blender, very important. We will also talk about this one. Redshift Matte Shadow Catcher, very good, and Redshift Skin, also a great one. And Redshift Subsurface Scatter, but we now have feature of subsurface scattering in the Redshift material. That's why for now, let's start with the Redshift material. It's now assigned to my object. I will start my IP here. I will maybe change my resolution to something more friendly. Let's see, we don't want Arnold render, we want Redshift, and we want a resolution of 1K, should be enough. And we say IP here. What happened with Redshift and the IP here is that the IP here is a progressive renderer, meaning as you can see, the image comes very quickly, and then it's refining. Look, if I move my camera and zoom it a bit, everything becomes very coarse and refine with each passes. We can see it here in the option. Output here. We have the progressive rendering. This is force for progressive for IP here, meaning I tell him that you render at the bare minimum 1024 pass and you stop. But I can obviously save my image before. Now, having done that, I have to keep in mind that some features are not accessible through the progressive rendering. Example, using subsurface scattering. Some of the subsurface scattering will not work with progressive rendering, and we have to do a proper render. We will not touch anything for now. We will go back to the material. What can we do with material? It's worked the same way as Mental Ray or V-Ray will be working. You have a material and everything is perfectly integrated into Maya. Here, that Redshift material, we'll call it base. We have access to some preset. Let's say copper. As you can see, we have nothing to reflect. This is why it's very important that we create some light. Create light, first we go with a dome light. Dome light being white, we have the same issue. It's whiter, but there's no reflection per se. That's why we grab our old trusty paper mill. Let's go there. Later we will start to use other IBL just to make it more fun, but for now we will keep this one going. Gnomon, HDRI, paper mill. Okay. And already you can see it's look way more interesting. What I can do under my feature, I can give more exposure. I can push the exposure. I can take off the exposure, right? No problem. So let's leave it at 0. I can change the hue. I can remove the saturation. I can do a lot of stuff. Again, when we do those hands-on project, we will move those slider and explain what they are doing. This is for the light, for the IBL light. I mean the forgot the name, the dome light. Yes, correct. Now we will create a new light, and it will be Redshift Physical Light. What the Redshift Physical Light is doing, it's roughly the same as think about it in the item of Aria Light. Let's zoom a little bit more here. Then maybe here we do that, and here we say look through selected, and we have our light selected, and we'll move it here. Here we can see the light actually in our render here. We'll move it up. It's outside of the camera. We can decide if it's visible or not. As you can see, I'm moving it down. You don't see it. I make it visible, and it's there. I make it invisible or bidirectional, meaning the light is casting light in both direction of the plane. So let's remove bidirectional and let's remove visible. And maybe we will make it a little bit bigger here. making the light bigger. It's like an area light again, meaning that it will cast more light. What can we do with that light? First, we can choose if we want to work with color or with temperature. Here I'm going to the warm, going to the cold. We can also choose what type of unit we want to use. If we have the proper physical value of a light bulb, then we could obviously use it. Ray contribution, this one is interesting. We will affect the diffuse or not. In this case, we don't affect the diffuse, or we don't affect the specular, or only the diffuse or the specular. And matte shadow emitter, we will look into it when we bring a shadow plane. So now let's move further. The scale, we can take down the scale of the diffuse, meaning it's still there, but we take it down, meaning right now it's not having any influence. Same with the glossiness. You can see I'm taking it lower, lower, lower. It's there, but not very strongly, and then boom, 100%. Let's place one. The shape is very interesting. You can use a rectangle, you can use a disc. I don't know if we will really see it on there. You can use a sphere, which will allow you to have a stronger light, but also more diffuse. We will change the intensity of the light to maybe 10 to start with. It's still way too strong. Let's put it at 1. You can see something is wrong in that area. I don't know what's going on. Oh, I know why. I will show you why. I have a sphere, right? If I make it visible, this is exactly what happened. Remember I told you I'm not cutting the video. I'm just living with my mistake and letting you see my mistake and me trying to figure out what's going on. In this case, my light was too big and was encompassing the head of the character. So I move that here. Here I'm still using a sphere. I could use a cylinder, probably not changing much. And I could also use a mesh. I could use a mesh to cast the light. But in this case, I don't need to do it. So we can show the sample of the light. If I put more sample, I will have less noise. We can look at the shadow to enable some feature, shadow transparency, but we don't have transparent in the scene. It's not really important for now. Contribution for the volume. That's one I will show a little bit later in this chapter. Photon is this if you want to have caustic, GI, image GI photon if you are using as a feature the GI that we will turn on here, and you are using PhotoMap, which I never or very seldomly use. Generally the way I do my GI is first I turn irradiance cache and brute force. Why? Irradiance cache allow me to have a faster calculation even if it's a little bit less accurate. In some instance, irradiance cache can be very slow if you have a lot of little object in the scene. Sometimes it's just better to stay with brute force 2 times. But for now, let's keep it this way. We will put the ray at 32 for brute force. We will keep it custom here, medium, medium. And if I do a render, let's move a little bit closer here. This is what we have. It should take less than a minute to render. Actually, it will be very fast. Yeah, see, a lot of reflection. It's noisy. I still have to adjust my values there and there, but it's actually a decent render, and we are at 10 seconds. Talking of decent render, let's zoom a little bit, and we can see we have some noise going on in those areas here and here. To combat the noise, I can go to my base, and I will say custom. First, I will tell him that I want to use IOR. I want IOR from 1.5, which is index of reflection. Excuse me. Turn on my IP here to see what's going on. And now I will start to see what my roughness is doing. We will take the roughness down. The color is here, should be in the white. Here, what are we doing? We are going to transparent, but we don't want the transparent. You see how quick and fast the render is. Now we have some eyes going on, maybe a little bit of blue here, somewhere there, and we keep on GGX. Everything is fine, and we do a render, and you will see that it's already way better. Now it will take a little bit more than 10 seconds because we are using feature that will tax the ray tracing process. That's actually not too bad. We are roughly now at let's see, I would say 30 seconds maybe. .28 seconds, not bad. Let's continue. Other feature. As I mentioned before, let's turn the IPA on again. And let's tell him you are plastic. Okay, you are actually a red plastic. So, and we will turn on some subsurface feature. Absorption scale. And obviously we don't really see what we're doing because IPA is not really giving a good feedback. That's why for that I need to come here and just press proper render. There's not much going on. We could make a transmittance color to be more like let's go with blue and turn on the subsurface multiple scattering here. As you can see, we start to have good result. Furthermore, we can change the radius of the layers, change the color of the layer, and it's allow us to do a skin, subsurface scattering skin. Now, do I want to go over each one of those? No, we will later go down as we do the project. We will look into them more individually. So as you can see, we have subsurface scattering going on. So that's for the subsurface scattering. What can we do with that material? Let's grab, maybe we will do something like that. We grab everything. We say custom, we go back to plastic, make it blue, and do an IPA render. We still have a lot of stuff to go over before we start on those projects. We go GGX, and we will grab the eyes. Always fun. We will lighting, shading, assign new material, and we will grab redshift incandescent. And here we have glowy eyes. Temperature is good, and then maybe we can do a render just of his face, just for fun. And we realize that the shader is also working with the GI.